Okay, so just a quick video about geometric sequences or geometric progressions. The sequences you've looked at already are arithmetic sequences, sometimes called linear sequences. And they're sequences where you're adding the same amount each time. So 3, 5, 7, 9, 11, that is an arithmetic sequence. 200, 400, 600, 800, that would be an arithmetic sequence. Okay, now you will have encountered these before. Geometric sequences are sequences where you are multiplying by the same amount each time. You're multiplying by the same amount to get from one term to the next term. So this first one, okay, 3, 9, 27, 81, we are multiplying by 3 each time. We're multiplying by 3, multiplying by 3, okay? So because it's a multiplying, okay, and we're multiplying by the same amount each time, that makes it a geometric sequence, okay? Here, we're multiplying by 2 each time, 8, 16, 32, 64. Here, it's a geometric sequence because we're multiplying by the same number each time, 4. Okay, so we're going to multiply that one by 3. Okay, 12 by 3, 36, multiplied by 308. Same here, we're starting on 5, but we're going to multiply by 3 each time. Now, to find the nth term, and you've been looking at nth term of an arithmetic sequence, to find the nth term of a geometric sequence, it's actually really straightforward, okay? 3, 9, 27, 81, and if we want to find the nth term, which we sometimes write as UN, first thing, you identify the type of sequence. We've already identified that it is a geometric sequence, okay? Find what the multiplier is, okay? So obviously this one, we're multiplying by 3, multiplying by 3. So that means it's going to be 3 to the power of n. Now, if we do 3 to the power of n for this sequence, okay, let's see what happens, okay? So 3 to the power of 1 for the first term, well, that gives me 3. 3 to the power of 2, that gives me 9. 3 to the power of 3, that gives me 27. So for this sequence, okay, the nth term would be 3 to the n. Now that's quite an easy one because it starts with the same thing we're multiplying by. Let's look at a slightly trickier one, okay? 8, 16, 32, 64. Okay, I've identified it's a geometric sequence, okay? We're multiplying by 2 each time. So it's going to have the form, the nth term, remember that just means nth term, is going to be of the form 2 to the power of n. Now let's check out how that looks, okay? 2 to the power of 1 is 2. 2 to the power of 2 is 4. Okay, 2 to the power of 3 is 8. 2 to the power of 4 is 16. Okay, so that's not yet what we want. Okay, I've got 2, I wanted 8. I've got 4, I wanted 16. I've got 8, I wanted 32. So I need to think, what correction do I need to make here? Okay, because it's a geometric sequence, you'll correct by multiplying because it's all about multiplying. Okay, so my correction would be to multiply by 4. Okay, 2 times 4 gives me 8. 4 times 4 gives me 16. Okay, times 4 in each case, times 4 times 4. So it will be, my final answer will be 4 multiplied by 2 to the n. We'll look at one more, slightly trickier one. Okay, and of course you can sub that back in, check your answers, substitute it in. 4 to find the first term times 2 to the 1, that's 4 times 2, which is 8. Okay, which is correct. Let's look at one trickier one. Okay, 4, 12, 36, 108. Okay, it's a geometric sequence. We know that because we're multiplying by 3 each time. Okay, that's the characteristic of a geometric sequence, geometric progression we sometimes call it. So I know it's going to be 3 to the power of n, okay? Let's check out how that looks, okay? 3 to the power of 1, well, that gives me 3. 3 to the power of 2 is 9. 3 to the power of 3, 27. Okay, so the correction here is obviously going to be a little bit harder, okay? It's not like where we just multiplied by 4 on the previous one. It's going to be a bit harder, so I need 3 multiplied by something gives me 4. Okay, well, that's going to be 3 multiplied by 4 over 3 gives me 4. Think about it, those two cancel through, so you're left with that. So my final answer will be equals 4 over 3 times by 3 to the n. So you've just got to work a little bit harder to find that correction. I often think about it like this: 3 times by what to make my correction to get there gives me 4. Well, you know, if I divide both sides by 3, that'd be one way to think about it, gives me that.